Welcome in .Cool. On the 1st of July, NASA detected a mysterious object, a nuclear-powered spacecraft sent by aliens. 3IATLAS was an interstellar visitor. 8 years ago, an interstellar object entered our solar system, the first of its kind ever seen from another world. It would become one of the most mysterious encounters in the history of astronomy. It was named Oumuamua. Unfortunately, we were unable to study it properly. By the time it was discovered, Oumuamua was already on its way out, and all that could be determined were its unexplained acceleration, unusual shape, and the absence of any contrail asteroidal characteristics. It was precisely these anomalies that led some scientists to propose an extraordinary hypothesis. Oumuamua might have been an artificial probe of extraterrestrial origin. However, what's happening now may overshadow the appearance of Oumuamua. At this very moment, another interstellar object is approaching at colossal speed, and its exact origin is yet to be determined. It received the moniker of 3IATLAS, and like its predecessor, it arrived from interstellar space. But this time, things appear even stranger and potentially far more dangerous. According to scientist A.V. Lowe and his colleagues at Harvard University, the object trajectory is too precise to be random. It looks more like a calculated flight path, as if someone had intentionally plotted and adjusted its course through the solar system with the possibility that Earth may be its main point of interest. Add to that its enormous speed. 3IATLAS is traveling almost twice as fast as most known objects in the solar system. And this visitor isn't just fast, it's a true giant. For reference, despite its mysterious nature, Oumuamua was relatively small, about 330 to 380 feet long, roughly the length of a football field. But this new object is hundreds of times larger. According to early estimates, its diameter could reach 6 to 9 miles, comparable to the size of Manhattan Island. With this in mind, the hypothesis of technological origin no longer seems like science fiction. As you're watching this video, 3IATLAS is approaching Mars's orbit and will soon begin its journey toward Earth. So, sit back and get comfortable. You're about to learn something fascinating. What exactly could this mysterious object be? Could its arrival be connected to Oumuamua's visit 8 years ago? And finally, should we be worried once it gets closer? On July the 1st of this year, the strange object was first spotted by astronomers in Chile among data from the robotic telescope of Atlas, which naturally raised concerns. You're seeing the first images, a tiny glowing dot racing through space against the backdrop of distant stars. What truly stunned scientists was the speed. It was covering over 130,000 miles per hour or 36 meters per second. For reference, the distance from New York to Los Angeles is about 2,400 m, a journey that takes about 6 hours on a passenger airplane. 3IATLAS could cover this distance in just 1 minute and 7 seconds. The speed of this object is so great that even the sun's gravity can't keep it in the solar system. Within 24 hours, NASA experts ran detailed calculations confirming the boldest suspicions. The object really arrived from interstellar space. At the moment of its discovery, it was within the orbit of Jupiter, about 327 million miles from us. As you're watching this, it's already covered much of the distance and is now approaching Mars's orbit, continuing its rapid approach toward us. Scientists named it 3IATLAS. Now, the key questions are what this object is and whether it could pose a threat to humanity. Harvard astronomy professor A. Loyd claims that we have every reason to believe we're not just dealing with a celestial object like an asteroid or a comet. He asserts that the object rapidly approaching Earth is a piece of technology from an extraterrestrial civilization, and according to him it may present a serious threat. Lowe and his colleagues Adam Hibbett and Adam Kroll came to this conclusion after conducting a thorough analysis of all available data on 3IATLAS. Their findings were truly shocking. The object trajectory through the solar system turned out to be unique, almost as if it were perfectly mapped. Currently, the object is heading toward Mars. On October the 2nd, it will pass about 17.5 million miles from the surface of the red planet. At first glance, that seems like a huge distance, but in cosmic terms, it's practically within arm's reach. Next up is Earth. On December the 19th, the object will reach a point of its closest proximity to our planet, about 167 million miles. This will be as close as it gets during its entire journey. Then comes Venus, and that flyby will be even closer, about 60 million miles. After that, it will head outside the solar system. But before that, On its return path in 2026, the object will pass Jupiter at just 33 million miles from the gas giant. Tracking its path, it emerges that the trajectory of 3IATLAS, as well as its speed, allow it to flawlessly pass close to 4 planets of the solar system, including Earth. Researchers deem this incredible. Their astronomical calculations showed that the likelihood of such a perfectly aligned route with that many close passes is less than 0.005%. In other words, in 99.995% of cases, an interstellar object would just zoom past without any noticeable interaction with any planet. But this one seems to be following a very deliberate trajectory. Avo believes that this is clear evidence of advanced technology. Most likely a spacecraft sent to study as many planets within our solar system as possible, including Earth. Inevitably, this raises a logical question. If 3IATLAS really is a spacecraft created by an extraterrestrial civilization, why wasn't its trajectory specifically designed to pass closest to Earth? After all, if the main mission is to observe intelligent life, it would make more sense to approach our planet as close as possible. Instead, the object will pass nearly 10 times closer to Mars and Earth. Could it be that to them, Mars is a more interesting research subject? Alab offers an explanation that's both perfectly logical and fascinating. In his view, this trajectory is not an accident, but a deliberate choice. If there is indeed an intelligent life form on board, it may be consciously avoiding too close contact. That's why the object trajectory is arranged so that the moment of its closest approach to Earth will be on the opposite side of the Sun. At that very moment, 3IATLAS will be perfectly illuminated by the Sun in a way that would allow it to be thoroughly studied using telescopes. But because the Sun will be right between us, we will in fact not be able to observe it. According to Lowe, this may not be a coincidence, but a deliberate maneuver. They want to study us, but don't want us to study them. The scientist's next hypothesis is no less surprising. If 3IATLAS is indeed a spacecraft, it may not intend to leave the solar system at all. Instead, it could use the gravitational field of the Sun or Jupiter by applying the so-called Earth effect. For example, if the ship chooses Jupiter, it not only needs to approach the planet as closely as possible, then activate its engines to adjust the trajectory and enter orbital motion around the Sun near Jupiter. Those same engines could then be used to slow down as needed. Similar maneuvers have long been used by our own scientists. Almost all planetary research missions studying the solar system use planets for gravitational assist to speed up or slow down the spacecraft by using gravity in combination with onboard propulsion. According to Alab and his colleagues, if the spacecraft is primarily an exploration vessel, then staying here longer is exactly what it needs to study us as thoroughly as possible. Another thing that fascinates Alab is the mystery of where 3IATLAS came from. Its path leads from a rather bright part of our Milky Way galaxy, which according to A.V. Loeb may not be a coincidence either because of the high density and brightness of stars in the area of the galaxy. The object remained invisible against their glow for a long while. Had it arrived from a region with lower stellar density, we would have spotted it much earlier. Lowe believes that if we had discovered 3IATLAS at least a year earlier, humanity would have had enough time to prepare and launch a spacecraft to intercept it, possibly even perform a successful landing. But it seems 3IATLAS doesn't want to become a target for our research. Avo entered the bounds of the solar system. Calculations show that at its speed of 36 meters per second, 3IATLAS crossed the outer boundary of the solar system, the hypothetical location of the Oort cloud, about 8,000 years ago. The scientist emphasizes that this was a time of remarkable changes taking place on Earth. Humanity was just entering a phase of rapid development. This time marked the emergence of early civilizations, the birth of writing systems, and the formation of large settlements. Perhaps, as Lab speculates, these events became the tipping point that drew the attention of someone from far, far away. But for what purpose? To simply study us? To make contact? ALO and his colleagues believe the true purpose of this object's visit might be far more alarming than it first appears. The scientist urges not to lose sight of a hypothesis known as a dark forest. This concept refers back to the famous question posed by Enrico Fermi, the Italian physicist, in 1950 during a discussion on the likelihood of extraterrestrial intelligence. He posed a question to his colleagues: where is everybody? The essence of his question is this: calculations and the laws of probability suggest that the universe should be teeming with intelligent civilizations. But if that's the case, why haven't we seen any signs of them? In other words, where is everybody? One of the darkest explanations for this paradox is the dark forest hypothesis. It suggests that intelligent civilizations do exist in the universe, but most of them are forced to hide. They strive to conceal their presence out of fear of detection by a more powerful and hostile life form, one that destroys anyone it perceives as a potential threat or exploits those from whom it can extract value. Considering the potential danger, other civilizations do everything they can to remain unnoticed, just as any creature in a forest risks being eaten if it makes noise or reveals itself. If 3IATLAS really is a spacecraft of extraterrestrial origin, it's logical to assume that its creators are far more technologically advanced than we are. At the very least, they are capable of interstellar travel, and that implies not only advanced propulsion systems, but also potential weapons at a level we've only ever imagined in sci-fi movies. Even if this is merely an autonomous reconnaissance probe with no living beings aboard, the fact that we may have been detected raises one of the most unsettling questions. Do those who discovered us have friendly intentions? Or are we facing a threat of becoming prey to an approaching predator? But what if we were detected even earlier thanks to another interstellar object? In 2017, the powerful Pan-STARRS telescope in Hawaii detected something unusual, an object hurtling through the solar system at incredible speed. After careful trajectory calculations, it became clear that this was the first interstellar visitor ever recorded in human history. The object was named Oumuamua, which in Hawaii means a messenger from afar arriving first. However, it raised the most intrigue after its discovery. By the time it was detected, Oumuamua was already leaving Earth's vicinity, which deprived scientists of the chance to study it in detail. Yet, the small amount of data that was collected at the time left scientists completely baffled. Originally, this foreign object was considered a comet, but that explanation started to crumble as more information emerged. First, it completely lacked a tail, which should have appeared as it approached the sun since the ice on a comet's surface typically evaporates under solar heat, leaving behind a bright trail of dust and gas. Second, Oumuamua suddenly accelerated, slightly changing its trajectory, as often happens with comets due to the thrust generated by evaporating materials, but again, no traces of outgassing were detected. Add to this the unusual shape of Oumuamua. According to various estimates, it was either elongated like a cigar or flat and disc-shaped, a form unlike any other known space object. Given all the unexplained things related to Oumuamua, it's not surprising that some scientists propose a hypothesis of its artificial origin. And now we may even have ground to suspect that Oumuamua might be connected to the approaching 3IATLAS. Just like Oumuamua, this new object also lacks a visible tail and exhibits an incredibly unusual trajectory. Furthermore, the size of these two objects make for an interesting comparison. According to preliminary data, Oumuamua was about 377 feet long and 364 feet wide, roughly the size of a standard football field. This makes it an ideal candidate for a reconnaissance probe, small, fast, and difficult to detect. The scale of 3IATLAS is on a whole different level, hundreds of times larger than Oumuamua, comparable in size to a small city. Drawing an analogy, we may be left with the impression that Oumuamua might have been a scout sent ahead to assess the situation, while 3IATLAS is a main vessel, possibly even a mothership following in its wake. Aleb, now the primary proponent of the idea that the object heading towards us is a spacecraft, first voiced a similar idea about Oumuamua back in 2017. After its sudden arrival in the solar system, Lowe was the first to suggest the possibility of an artificial origin. While most scientists tried to find natural explanation for the object's strange behavior, Lowe was practically the only one defending his hypothesis. Over time, the scientific community reached a consensus. Oumuamua was most likely an unorthodox comet. Its strange shape, whether elongated like a cigar or flat and disc-shaped, is now attributed to the limitations of our observation ability. Perhaps these shapes are not so rare in interstellar space. We just haven't had the chance to study them until now. The mysterious acceleration of the object, which caused so much debate, was also eventually explained. Similar to other comets, the acceleration may have been caused by gas emissions from the object's surface. Unlike typical comets, Oumuamua likely contained very little dust, and therefore its gas tail was nearly invisible to our instruments. But what about 3IATLAS? Does it pose a threat to us? Most scientists agree that Lowe and his colleagues' assumptions about the object are fundamentally incorrect. Astrophysicists are almost certain that what's approaching us is nothing more than a massive comet, and they have a number of reasons for this conclusion. First, Lowe's earlier claims about the comet lacking a dust tail do not align with observations. For example, in a recent photo, you can see a faint glow surrounding the comet. This is a cloud of gas, ice, and dust that forms around every comet as it nears the sun. Its current intensity is weak, but it will grow brighter and larger as it approaches our star. Moreover, the object's brightness also indicates that we're likely dealing with a comet rich in ice. Since ice reflects sunlight well, the object appears bright even at a great distance. On the left, you'll see a collage of images taken in different spectral bands, tracking the object's movement against the stellar background, clearly visible along with its intense brightness. And on the right, you can spot a faint but noticeable dust tail. But what about its mysterious trajectory estimated to have just a 0.005% chance of occurring randomly? Researchers have no definitive answer for that. The trajectory of 3IATLAS is truly unique. It allows the object to pass relatively close to 4 planets in the solar system, and yet it doesn't provide an opportunity to observe Earth. At its closest approach to Earth, 3IATLAS will be about 167 million miles away, almost twice the distance between Earth and the Sun, which begs a logical question. If the object's goal is to study humanity, why come so close yet remain so far out of reach? Why not choose a trajectory that brings it closer, like passing by the moon, for example? What's the point of crossing interstellar space only to remain a distant observer? Samantha Lawler, an astronomer at the University of Regina in Canada who specializes in solar system dynamics, asserts that all data indicate that this is an ordinary comet ejected from another solar system, just like countless billions of comets that have been ejected from our own. The size of 3IATLAS is also not particularly extraordinary. At first glance, an object with a diameter of 6 to 9 miles may seem very large, but keep in mind that we're dealing with a space object. For reference, the famous Hale-Bopp comet, which you could see with the naked eye in 1997, had a diameter of about 46 miles. The Bernard-Donnelly-Bernstein comet, discovered in 2021, was an astonishing 85 miles across. So, despite its impressive dimensions, 3IATLAS is far from being the largest known comet. Its size is not out of the ordinary and cannot be considered evidence of artificial origin with any degree of certainty. Virtually the entire scientific community is now confident that 3IATLAS is a comet, and not just any comet, but a rare and exceptionally valuable one. Named after the telescope that first detected the object, the designation 3IATLAS reflects its importance from a scientific standpoint. The letter I stands for interstellar, indicating its origin from beyond our solar system, and the number 3 signifies that this is only the third interstellar object ever recorded by humanity. The first was a mysterious Oumuamua discovered in 2017. The second was a comet 2E Boris discovered on August 30th, 2019. And now there's 3IATLAS. As we can see, such visitors are extremely rare, and every opportunity to study them is a window into distant corners of the universe inaccessible to our space probes. Right now, 3IATLAS is rapidly approaching the Sun, and scientists have a rare, if brief, chance to observe it up close. This observational window will be short, but it may offer crucial clues about the object's true nature while it remains within view. But as we await a final answer to the question of what 3IATLAS truly is it worth going back to 2017? That was when Oumuamua passed through the solar system, becoming the first recorded interstellar object. And while with 3IATLAS, we have a chance to observe everything in real time. In the case of Oumuamua, we never had that opportunity. It passed by us, leaving behind more questions than answers. But scientists are not ready to let it go. They have proposed a large-scale mission called Project Lyra. Its goal to send a spacecraft to intercept Oumuamua to get close and finally determine what it really is. Right after the discovery of Oumuamua, a wave of excitement spread through the scientific community. This object didn't fit into any known category, and no one could say what exactly we had encountered. It challenged everything we knew about space. Astronomers around the world urgently reproposed their telescopes, canceled their own research just to catch a few more signals from before it vanished forever into the darkness of interstellar space. Initial estimates shortly after its discovery suggested that Oumuamua was about 1,300 feet long and only 130 feet wide. This elongated cigar-like shape didn't resemble any known celestial body. But later, as new data arrived, scientists at McMaster University in Canada made their own calculations, suggesting that its dimension could have been around 380 feet in length, 364 feet wide, and 62 foot thick, making it slightly larger than the Statue of Liberty. However, instead of an elongated cigar shape, the object might have been flat to pancake-like in form. But even that shape is very unusual for space objects. Similar proportions have only been seen in rare cases such as Erikov, a celestial body in the Kuiper belt beyond Neptune's orbit. Even so, such exceptions don't make Oumuamua any less mysterious. Its shape remains extremely atypical and continues to raise questions. We're observing something unusual and mysterious. An object hurtling through space at an incredible speed of 16 meters per second. That's faster than Voyager 1, one of the fastest spacecraft ever launched by humans. At such a speed, Oumuamua could cross the distance between New York and San Francisco in just 2 minutes and 38 seconds. This velocity indicated that the object was not bound by the sun's gravity, and soon this suspicion was confirmed. It was a distant interstellar visitor. But where exactly had it come from? And more importantly, what was it? The first thing astronomers expected to see as they observed the rapidly receding object was a bright tail of gas and dust. After all, they initially assumed it was a comet, and those behave predictably when approaching sun. Under the influence of solar heat, ice and frozen gases on their surface begin to evaporate, ejecting dust and gas into space. These emissions form a glowing tail that trails behind a nucleus reflecting sunlight. A vivid example is Comet Hale-Bopp, whose tail was visible to the naked eye from Earth in 1997. Music, but Oumuamua defied all expectations. It flew past the sun without leaving any trace of evaporation. No gas, no dust, not even the faintest hint of a tail. Its behavior broke all the rules that apply to ordinary comets. This mysterious guest continued to baffle science. Its shape, trajectory, and incredible speed all pointed to one thing. We were dealing with something completely unique. Unlike any object known to humanity, tension continued to grow in the scientific community. The main question was, is Oumuamua just an ordinary cosmic body, or have we for the first time encountered extraterrestrial technology? But the strangest part was yet to come. It turned out that Oumuamua had accelerated. And not just accelerated, but had done so in a way that defied understanding, as if it were following its own plan. Scientists determined that 40 days before its discovery, the object had passed dangerously close to the sun, just 23 million miles from its surface. And it was after this moment that it suddenly gained speed. At its peak, Oumuamua accelerated to 54 meters per second, 3.5 times faster than before its flyby of the sun. That speed is truly astonishing. It was 5 times faster than Voyager 1. It is currently traveling 11 times faster than the Starship rocket and 250 times faster than the speed of sound. This kind of acceleration is typically observed in comets when jets of dust and water vapor from their tail give them an additional boost. However, as we already mentioned, Oumuamua showed no signs of such activity. Something accelerated it. But what Oumuamua spaceship? What if this object isn't what it seemed to be? What if 8 years ago something far more intriguing than a chunk of space ice or rock flew near Earth? Perhaps a spacecraft created by another civilization. This is a hypothesis put forward in 2021 by astronomer AVI, then chair of Harvard University's astronomy department, along with his colleague Shmuley. They propose that the first detected interstellar object may have been a space probe. The researchers are convinced Oumuamua's strange behavior gives every reason to suspect that it might be something truly unorthodox. What intrigued scientists most was the moment the object unexpectedly accelerated during its pass by the sun. Sure, the sun's gravity could give it a push, but based on calculations, that acceleration should have been much weaker. That's why Alio and Shuley proposed a hypothesis. What if this wasn't just a rock from another star system, but an object using light sail technology? At first glance, the idea sounds fantastic, but it's based on real physics. A light sail is a thin and lightweight structure that can move using the pressure of light. Streams of photons from the sun, for example, exert a tiny but constant pressure on the surface of a sail, gradually accelerating it to very high speeds without the need for fuel. If Oumuamua had indeed such an ultra-thin structure capable of catching solar radiation pressure, then the solar wind could have given it the extra push. According to their calculations, for this to be possible, the sail's thickness would need to be just 0.3 to 0.9 millimeters, about the thickness of a human hair. Just imagine an object 380 feet long and less than a millimeter thick. They may sound wildly unrealistic, but light sail technology already exists. For example, it was tested by the Japanese spacecraft Icaros, the world's first probe to successfully use solar radiation as a propulsion source, which successfully journeyed toward Venus in 2010. Perhaps Oumuamua was something like that, an object equipped with a solar sail designed to accelerate and change course as it passed by star systems. And if it truly was an artificially created device, it's entirely possible that in addition to the sail, it had other technological components, ones we can only speculate about for now. But one thing seems obvious. An object like this would need at least a system for scanning its surroundings and a means of communication to transmit data or receive signals from its creators. Bialy and Lab also conducted calculations to determine whether Oumuamua's light sail could withstand a long interstellar journey. They considered the density of interstellar gas and dust as well as the speed at which the object would collide with these particles in space. The results were impressive. If Oumuamua really was a device like that, it could have traveled at least 16,000 light-years from its home star system while remaining intact. That said, the scientists themselves don't definitively claim that Oumuamua is a spacecraft. They simply believe that the possibility exists and that it's serious enough not to be dismissed in scientific discourse. If we assume that Oumuamua truly was an artificial object, the idea of a solar sail is just one possible version. It might have been a much more complex and advanced probe. For example, an active unmanned spacecraft sent out to study our solar system, and there are reasons to believe that it was indeed unmanned. Consider this. Oumuamua's speed would allow it to travel 1 light-year in roughly 11 to 11.5000 years. Now compare that to the distance to the nearest star, Proxima Centauri, just over 4 light-years away. That would mean the trip would have taken the Oumuamua around 44 to 46,000 years. Such journeys are simply impossible for living organisms, which means that if this was a ship, it was most likely controlled remotely, either by a program or by someone from afar. However, not everyone shares this point of view. Many scientists consider the idea of a possible spacecraft or artificial object to be overly speculative. In their opinion, there simply isn't enough direct evidence to support such bold claims. Scientists Alan Jackson and Steve Desch from Arizona State University proposed their own hypothesis about the nature of Oumuamua. They suggest it may be a fragment of frozen nitrogen. This type of substance can be found, for example, on Pluto. When the spacecraft New Horizons flew past the dwarf planet in 2015, it observed icy plains like Sputnik Planeta, vast lakes of frozen nitrogen. The researchers suggest that a powerful impact could have broken off a chunk of such a surface from a Pluto-like planet, which then embarked on an interstellar journey. As it approached the Sun, the nitrogen began to evaporate from the heat, creating a kind of jet propulsion that could explain the object's sudden acceleration. Meanwhile, 2 other scientists, Darryl Seligman of Cornell University and Jennifer Borgner of the University of California, Berkeley, have their own explanation for this mysterious object. According to them, Oumuamua was once an ordinary water-rich comet orbiting a distant star, but at some point it was ejected into interstellar space. During its long journey through the galaxy, it was exposed to powerful cosmic rays, for example, from supernova explosions. These rays could have transformed up to a third of its water ice into hydrogen molecules, which remained trapped inside the ice. Later, when the Oumuamua reached our Sun, it warmed up and the accumulated hydrogen started to escape like tiny jet streams. This is what gave the object an extra push. And the unusual behavior, such as a lack of a bright tail like typical comets, is explained by the fact that light hydrogen wouldn't generate enough for us to carry much dust with it. As a result, we see strong acceleration without any visible trail of dust or gas. Other scientists also share similar ideas to explain this puzzling object. Some go for even simpler hypotheses. Karen Meach, an astronomer at the University of Hawaii at Manoa, believes that the object is simply a very ordinary comet, but with a very low dust content, hence the lack of a tail. And the unusual shape of Oumuamua, perhaps it's not so rare at all. The fact that it seems atypical to us may simply reflect our limited experience. The universe contains a vast diversity of forms and structures, and a cigar-shaped or disc-shaped object might be much more common than we think. Most of them are likely just too far away for us to observe. Although the majority of the scientific community agrees that Oumuamua is most likely an asteroid or an unusual comet, we still have no definitive confirmation of this, which means a central question remains open. How can we ever truly know what this mysterious interstellar visitor really was? Music, a bold mission to catch up with Oumuamua. It's simply impossible to see or discern Oumuamua even through the most powerful space telescope, as the object is rapidly moving away and is extremely small, almost 3.5 times shorter than the height of the Empire State Building. Seeing such a tiny object at a distance of billions of miles would be like trying to spot Sydney from the shores of San Francisco across the entire Pacific Ocean using ordinary binoculars. Only the Hubble Space Telescope was able to observe this object for a few weeks before it completely faded into darkness. But what if we try to catch up with this object and study it up close? The idea certainly sounds bold, nearly impossible, but that's exactly the challenge scientists have taken on. As early as October 30th, 2017, just 11 days after the discovery of Oumuamua, researchers from the Initiative for Interstellar Studies announced the start of Project Lyra, aimed at assessing whether it's possible to design a mission that would send a spacecraft after the interstellar object and study it up close. But is such an ambitious mission even feasible? Engineer and scientist Adam Hibbert, a key participant in Project Lyra and the creator of the Optimum Interplanetary Trajectory software or its use for calculating optimal trajectory for interplanetary missions, is convinced the mission is not just about finding out what Oumuamua is. It's a chance to make a breakthrough in our understanding of the entire interstellar realm. According to him, the first step is to create a truly unique probe capable of withstanding the harsh conditions of deep space. It must be reliably protected from radiation, as it will need to travel billions of miles where cosmic radiation is relentless and can easily disable its scientific instruments. Of course, catching up with Oumuamua is not an easy task, but in space mission practice, we already know how to achieve extreme speeds without using massive rocket engines or enormous fuel reserves. As part of Project Lyra, engineers plan to launch a probe on a dizzying journey using gravitational assist as massive cosmic slingshots. One of the proposed trajectories is a true planetary dance. The probe would launch from Earth and head towards Venus, where it would receive its first boost. Then it would return to Earth to use our planet's gravity for a second acceleration. The next step would be to fly toward Jupiter, where the gas giant's immense gravity would give the spacecraft a final push on its way toward the interstellar traveler Oumuamua. Additionally, the probe would be equipped with chemical propulsion systems that could fine-tune its trajectory and provide additional thrust at the right moments. Because in an interstellar chase, every mile per second counts. This trick has already stood the test of time. In 1979, the Voyager 1 and Voyager 2 spacecraft used Jupiter's gravity to accelerate dramatically and head toward Saturn. Today's engineers aim to replicate this maneuver, but this time to catch up with Oumuamua. There's also another far more daring plan known as the solar off maneuver. In this scenario, the probe would first travel to Jupiter, then reduce its speed and use a giant planet's gravity to change course and head toward the sun as close as physically possible without catastrophic consequences. There on the edge of hell, it would receive a massive gravitational boost from the sun and additionally ignite its chemical engines to escape the sun's pull. Then at incredible speeds, head back to Jupiter, using its gravity once again for acceleration and finally entering a trajectory to pursue Oumuamua. If everything works out, the spacecraft could accelerate to 74,000 miles per hour or even up to 163,000 miles per hour. That's 20 to 45 meters per second, precisely the speed range needed to catch up with the fleeing mystery object and to do it fast enough. But there's a serious obstacle: the colossal temperature. Approaching the sun so closely could heat the probe to 1,400 degrees Celsius, hot enough to melt metal. However, we already have a proven solution: the Parker Solar Probe, which in 2024 set a new record by approaching the sun at just 3.7 million miles, all thanks to its unique heat shield made of carbon foam, which would to the infernal heat. A similar shield is planned for the probe destined to chase Oumuamua. In fact, engineers have already created a 3D model of the spacecraft. Scientists have not yet made a final decision on which route to choose for the probe: the gravity assist dance involving Earth, Venus, and Jupiter, or the perilous solar flyby. Other more exotic methods are also being considered. For instance, laser propulsion, in which a powerful ground-based laser pushes a probe through space, giving an acceleration without a drop of fuel. Or the previously mentioned solar sails, lightweight structures that capture the pressure of sunlight and gradually but surely accelerate the spacecraft across the cosmos. For now, these technologies are more experimental than practical, but they open the door for a new era of fast and efficient interstellar travel. As for the mission to reach Oumuamua, its launch is tentatively scheduled for sometime between 2030 and 2033. The most realistic scenario at this point involves a gravitational dance using Venus, Earth, and Jupiter. In this case, the probe will be able to catch up with the fast-receding Oumuamua in the early 2050s and perhaps for the first time in history come face-to-face with a messenger from another star system. But what if the mission fails? What if the probe is unable to catch up with Oumuamua? What if it approaches the object from a distance too far away to study it properly? Don't forget that this object is extremely small, emits no light, and sends no signals. Spotting it in deep space is nearly impossible. There's another risk. The probe could reach its target but fail to slow down in time. In that case, it would simply speed past, missing what might be our only chance to get close to our elusive target. Scientist Adam Hibbert believes that even in the event of failure, the mission would not be considered a failure. Even if Oumuamua can't be caught, the probe will become a first spacecraft in history to be purposefully sent beyond the boundaries of the solar system. The attempt to chase Oumuamua is also a chance to study the space beyond the solar system and to explore the universe from an extrasolar perspective, which could bring humanity countless benefits, the scientist asserts. To date, only two objects have crossed the helipole, the boundary where the sun's influence ends and interstellar space begins. These are Voyager 1 and Voyager 2. But their journey beyond the solar system was more a matter of luck. No one expected the probes, which were designed to study planets to travel so far or for so long. Unlike them, the new probe is being designed from the outset to venture into interstellar space. It will be equipped with state-of-the-art instruments capable of gathering valuable data about the environment beyond the solar system, data we just don't have. In that case, the probe would not only have a chance to catch up with Oumuamua and answer the question of what this object really is, but also to transmit invaluable data about the mysteries of interstellar space. But what exactly do scientists hope to see if the probe does manage to reach Oumuamua? As already mentioned, most researchers believe this mysterious visitor is nothing more than an unusual comet or asteroid. It's assumed to be a dense object composed of rock and possibly metals. It contains no water or ice, and its reddish surface likely results from exposure to cosmic rays over millions of years. Once scientists formed a general idea about the composition of Oumuamua, it begged the next question just as important. What kind of journey brought this object to our solar system? The answer to its true nature might lie not only in what it's made of, but where it came from. In 2018, astronomers attempted to reconstruct its trajectory retrospectively. Calculations showed that about 1 million years ago, it flew past several stars coming closest to the red dwarf HIP 3757. It's possible that its interstellar journey began there heading directly towards us. Another version suggests that Oumuamua might have come from the Vega star system in the Lyra constellation about 25 light-years away. So far, astronomers haven't found any potentially habitable planets in that region. But that doesn't mean they are not there. It's quite possible that somewhere near Vega, a civilization exists that's responsible for the appearance of this mysterious object. And all the excitement is stirred up in the scientific community. Now, Oumuamua is speeding toward the constellation Pegasus, continuing its strange voyage through space. By the end of 2025, the interstellar visitor will reach the outer edge of the Kuiper Belt. And by November 2038, just 13 years later, it will reach the helop, thus exiting the region influenced by the solar wind and entering true interstellar space. Music. It appeared very suddenly and disappeared just as quickly, leaving behind more questions and answers. Its fleeting presence stirred the scientific community, and now researchers are determined not to miss the next such visitor from the depths of space. The European Space Agency is preparing a unique mission called Comet Interceptor. Its goal is to intercept objects arriving from interstellar space. But the main challenge is that these kinds of guests arrive at incredible speeds, and there simply isn't enough time to prepare and launch spacecraft once it's spotted. Therefore, ESA has made a bold decision. In 2029, they plan to launch a stakeout probe into space, which will be stationed at the rangy point L2 about 930,000 miles from Earth. This is a location where the gravitational forces of Earth, the Moon, and the Sun balance out, creating an ideal observational outpost. There, the probe will wait patiently, and as soon as an interstellar comet appears on the horizon, it will activate. The main probe will release two maneuverable satellites that will pinch the target and begin observation from multiple angles simultaneously. Most scientists today believe that Oumuamua is an ordinary cosmic body, most likely a comet or asteroid. Others suggest that we're dealing with technology from another civilization, but we cannot confirm either hypothesis yet. The object is already too far away, and its nature remains cloaked in mystery. The chase for the truth seems almost impossible, expensive, risky, and absurdly ambitious. But it's precisely these kinds of mysteries that fire up the imagination, and the desire to know the truth outweighs all obstacles. And what do you think flew past us in 2017? And should humanity spend resources on such missions? Share your opinion in the comments. Thanks for watching Dark Core.